Hi, welcome to the video on the example problem for the 4.4b note. In this problem, you are asked to calculate the equilibrium constant for a reaction. And here are some key details for that reaction as told in that problem. They tell you that the reaction is at equilibrium, and they give you the concentrations of the reactant, N2O5, and the products. So the concentration of the reactant is 0.5 molar is a unit to measure concentration, like grams is a unit to measure mass. Concentration of NO2 is 2.0 molar, and concentration of O2 is 0.5 molar. Okay, so then here's the balanced chemical equation. We have 2 N2O5 in the gas phase in equilibrium with 4 NO2 in the gas phase and an O2 in the gas phase. So to write the equilibrium expression, remember that's products over reactants, and that's our first step, is to write that equilibrium expression or equation. So the way that we do that is we're going to take our products. My first product is NO2, the concentration, I put it in brackets. Remember the brackets mean concentration. And you raise it to the power of the coefficient in front, so I'm going to raise it to the fourth power. And then the same thing for O2, that's our second product, and raise it to its power. Now the coefficient in front is an invisible 1, so the power here is an invisible 1, so we don't have to worry about changing that. Now these values are multiplying together, so this says NO2 raised to the fourth power times concentration of O2. All right, in the denominator we're going to put our products, which is N2O5, and we're going to raise that to its coefficient second. Okay, so we have our expression. Now all we need to do is just plug our numbers in to solve. So that's our last step. So I'm going to write K again underneath here. And we're going to start with NO2, nitrogen dioxide. That has a concentration of 2 molar, so I'm going to put 2. And I'm going to raise 2 to the fourth power. And then I'm going to multiply that by the concentration of O2, which is 0.5. Okay, so that's in my numerator. And in my denominator, I'm going to have N2O5, which its concentration is 0.5, raised to the second power. So just take the 0.5 and plug it in for the concentration. So 0.5 raised to the second power. Now, of course, you could, if you were doing this without a calculator, you would probably do things like simplify it first. But I'm just going to go ahead and plug it into the calculator. If you're doing this without a calculator, use scientific notation and simplify things. For example, this 0.5 can cross out in the front, leaving with just in the numerator, leaving you with just a 0.5 in the denominator. And then you would take 2.0 to the fourth power and divide it by 0.5. But I'm going to do it in the calculator. Okay, so 2.0, I'm going to raise that to the fourth power, get my value, that's 16. And then I'm going to multiply that by 0.5, and that's my numerator done. So I have 8 in the numerator. And then the denominator is going to be 0.5 squared. Now 0.5 squared I know is 0.25. And in the calculator I'm just going to put that in. My answer, 8 divided by 0.5 squared. And then I get my K value of 32. Okay. Now, because K is larger than 1, it gives you an indication of, in terms of the ratio, the numerator, you have more in the numerator. However, in order for a reaction to really be favored to the right, you usually need a much larger K value, because part of the reason why you have a larger numerator is just because you have more pieces in the denominator. Anyway, I hope you, on the product side. So of course you're going to have a larger numerator. Anyway, I hope you found this video helpful on how to calculate K. There are no units for K, by the way. It's just the value that's written. And have a quality day.